Hey guys, Adam here with yet another Punch-Out repair for you. I know, how long has it been since we did Punch-Out? It seems like forever that I've been able to do any repairs, but here we have another Punch-Out to fix, and this one is from cyborg2000 over on KLOV, and he was reporting some issues with, I think, the lower monitor background graphics. So let's fire this up and let's see what we have to start with. We got sound, that's always a good sign. Don't have to replace the sound of speech. See that weirdness going on there? What's up with that? So upper monitor, this is lower monitor. Upper monitor looks pretty good so far. Lower monitor that's not good. So some weirdness going on. Black screen. Upper screen still looks fine. So there's nothing here. Okay. Alright, so we have our opponent sprites, our player sprites, and it looks like the background is just all messed up. Not only is it, oh, there's Donkey Kong right there. You guys see that? I didn't know he was in the game. Not only is it messed up like position wise, but it's messed up color wise and graphically. Like these are the wrong characters being displayed. Let's take another peek at the upper monitor. See, the upper monitor is solid. I think we're all set with that, which is good news. And it's just the lower monitor background, which is good because that is basically just the background PCB that drives that. The opponent and the opponent and the fighter video stuff all gets generated on the middle PCB. You guys have heard me say this a million times. All the background is on the back PCB, obviously. So what's nice is that I don't have to take this whole stack apart. I can just flip it over and start poking around with that guy. So these are the schematics for the back PCB. And all of the characters and stuff that get generated for the upper monitor are kind of up in here. These are the upper monitor character proms. This, I believe, is the upper monitor RAM that drives those. But for the lower monitor, what we're working with today, the ROMs are here. These are the character ROMs, and then this is the RAM that basically drives that. So seeing as how, of course the picture is gone, but seeing as how not only was the data wrong, but the locality of where stuff was being drawn was completely off, I think it's probably address and data problem on this RAM, and I think it might actually be on the right side as opposed to the read side. So the CPU is trying to drive the right contents into the RAM, but there's something here that's mucking up the works, and either it's driving the wrong data or it's driving it's writing to the wrong location in the RAM. Probably both, because once the CPU does that, basically it's put to the side, and then the horizontal and vertical address counters kind of take charge there, and they start drawing the screen using the contents in here. So if we write garbage, we're going to get garbage, and I think that might be what we're seeing here. We'll know more as we poke into this. So anyway, this is what we have to start with. So why don't we flip this guy over? We'll get the logic probe out, start poking around, and see what we can find. So these are the RAMs in question, 3H and 3J. And I basically probed all around to make sure that nothing's kind of just held static, either 0 or 1 all the time. Everything's wiggling, and that's good. Everything is moving. So I think what I'm going to do is actually use the fluke to kind of drive some patterns in here. Maybe flood the RAM with zeros or flood it with ones, and then I can check out on the output side, am I always reading zeros and reading ones? If I flood the whole thing with ones, and then I start reading and I see it toggling, in other words, it goes as I'm reading it from a 1 to a 0, well, that shouldn't happen. The whole thing should be filled with ones, and vice versa. So that's kind of typically how I solve these kind of issues. Flood the whole RAM with a known pattern or a known value, and then look for weird stuff coming on the other side. Another thing I'll do too is I'll flood it with ones, and as I'm flooding it with ones, I'll take a look at the right side, the data going in, and make sure that it is actually ones. I've seen cases where it's zeros, and that tells me, the logic, between the CPU and here is getting corrupted somehow. The data is getting inverted, or some other weird thing is going on. So let me throw the fluke on here, and then we'll fill it with some patterns, and then we'll see what happens next. So as you can see, we got the logic analyzer hooked up. I did use my logic probe, and I was looking at the data that was being read out, and I saw ones and zeros and all sorts of madness. So to get a better understanding of what's going on, I threw my logic analyzer on here. So this is what we're seeing. I just have it kind of running freely right now. You can see the data's up on top, and it's bouncing around between zeros but also ones and other values. Output enable, chip select. This is the one that intrigues me, write enable. So right now the CPU, the Z80 that's on the CPU PCB is not in control. In fact, I unplugged it and it's sitting right there. We are in control. We have the fluke plugged into it, and we're acting as the Z80, so to speak. And so right now I ran a program to fill it with zeros, and we're just sitting idle right now. We shouldn't be doing anything. But if you look, you can see the write enable is going all over the place. Every once in a while it'll burst. There you go. And so something on the PCB is corrupting this write enable signal, and when that happens, we're just writing garbage or whatever into the character RAM. And so that's not good. So I need to start with the write enable, which is right here. Where does it go? It goes back to the write signal actually on the CPU PCB. So I need to probably flip this board stack over and start looking at the write circuitry and see what's going on there, because there really shouldn't be anything going on. Actually, no, I take that back. So we have DMA stuff going on here. That's right. I forgot all about this. It's been so long since I've worked on a Punchout PCB. So the main video RAM is actually not on all of these various PCBs, the video PCB and the back PCB. It's on the CPU PCB, sitting up here at the top. And so we write a bunch of stuff into that, and then we has what's called DMA, which takes a copy of that and sends it over to the video PCB and the back PCB. And I think that's what's going on here. I don't have the address bits hooked up, but I do believe that's what's causing the problem. That being said, I did flood these with zeros, and so there should be no reason that while that write enable, that burst, toggles, and we could probably set up a trigger here. Let me just do that real quick. Okay, so I have it stopped here when we're writing, but you can see here that while I'm writing, I'm actually writing ones and zeros, and I should never see that, right? It's basically supposed to just take a copy of what's in here, send it over to the back PCB, and this should be filled with zeros, and it's not. It's ones and zeros. So it could be something as simple as the buffering on the back PCB, because the data that comes from that goes to the back PCB rather comes from the CPU PCB through these buffers. So I'll check those and make sure that those are okay. And if those check out, then it's probably something on the CPU PCB, and we'll have to kind of take a look at this DMA circuitry and see what's going on there. Probably is a good idea for me to do some RAM checks actually before I go ahead and do that, because why waste my time debugging this and this if it's really just a bum RAM or something weird that's going on. So anyway, I think I'll do that first. I'll just do a real quick RAM check and make sure things are good with the fluke, and then if RAM checks come out okay, I'll take a look at this area. And if that checks out okay, then we'll have to start poking at the DMA circuitry, which is in this corner of the CPU PCB. So RAM checks look good, and so now I'm just looking at this section here, right, the buffers, or the drivers I should say, that I spoke about before. And I'm already starting to see some weirdness. So this is what's getting sent from the CPU. When this guy gets enabled, it passes through to the other side. And so I'm just calling this the inside, and this is the outside. And so I'm looking at data line 0, D0N, and you can see it's low all the time. And then G1 is the enable to that driver. So when G1 is low, then the driver is enabled, and whatever's on the inside will pass on to the outside. And you can see the outside is bouncing all over the place. Now, I don't think it's necessarily a problem with this driver because of the way that it's doing this. If it was like random glitching and stuff, I'd say, yeah, maybe it's messed up, but it's like perfect, square wave here. So I'm wondering if it's something else on this side that would be receiving the data, but the chip is bad and it's actually back feeding, this clock or this pattern onto the signal. There's other stuff that gets tied to that. So this is the RAM that we were looking at before. He uses that data bit, but so do these counters, and so does the ROMs themselves, the character ROMs. Of the three, the one that I'm kind of suspicious about is this guy here. Why? Because he's a counter, and so when you count in binary, you see these kind of patterns before, So I think that it might be this guy here. Actually, where am I pointing? I think it might be in this little section right here. So I'm going to go ahead and probe a little bit more with Logic Analyzer and see if I can figure out what's going on. Maybe lift that trace. I know it's going to mess up what's going on the screen, but I don't really care from a logic perspective. I just want to make sure that this is sound. And so yeah, so let me hunt around a little bit more in this area, and then I'll report back. Yeah, I spent a good 10 minutes here playing around with this section. I'm not really seeing, I don't know. I'm looking for patterns that might be driving back, feeding onto that signal. I'm not seeing it. I think it might just be this driver here. I got a ton of these, so I'm just going to swap this out real quick, and we'll see if that improves things, and then go from there. Alright, we got our new 244 in there, and let's see if that changed anything. Oh, okay, so that's a good sign. I see my graphics down here, my characters, and they're not getting all glitchy. So let it play through a little bit. Wow! Look at that! So it was just that one driver, 4K, sitting right here, that was messing up the whole works. Let's let it play through a little bit. I really want to see the background. Make sure the background is in good shape. Look at that. Awesome. So I think what I'll do now is just flip it over, get rid of the fluke here, take all that business off, make sure we have speech, and then we'll go from there. Alright, let's fire it up one last time, make sure we got sounds. And I keep saying this, but you know, I do want to get a super gun where I actually have the coin button, so I don't have to use the wire method, but I've just been so busy. Anyway, let's fire this up, and we'll cheat here, use our cheater method. So we'll put a coin in here. Okay, waiting for that. And 20, 19, 18, 17. And we're counting down. So let me switch over to speech once we count down here. Switch over. There we go. Very good. Beautiful. Yeah, and I do want to add, like, eventually what I would like to do too is create a single board for this, because this is my setup and it's been it for years. But I'd like to mix the sounds together, you know, mix them together, I should say, so I don't have to switch between the sounds. Video, I'll probably have to switch between the video. But anyway, it never ends, right? There's always a never-ending list of projects and stuff. Anyway, back to the board. I think we're in good shape. I think this is going to be okay. I'll just run it through its motions a little bit and make sure everything's working well here. But yeah, we lucked out on this one. Just ended up being that one buffer. It took us a while to find it, but we got there. And so yeah, that is it for this one here. So I'm trying to think of what's on my list of things to do. I do want to do a video that kind of goes over the logic analyzer. We're getting a lot of requests for logic analyzer type stuff, and also oscilloscope stuff. So I'll probably do like an all-in-one that kind of describes the differences between, say, a logic probe and a scope and a logic analyzer, why you would want to use them, is one better than the other, that whole business. That by far I think is one of the biggest questions I get from people who are looking to get into doing arcade game repair. So that'll probably be next. But anyway, I think that's it for this video, guys. As always, thanks for subscribing and for liking and all that good stuff. God bless, and we'll catch you on the next one. Thanks for watching, guys, and hey, if you like this video, don't forget to subscribe and check out some of my other videos on arcade game repair. Oh, seriously?